So the idea of a degree of freedom refers to a quantity that is used to represent the location and the orientation of a part in three-dimensional space. If you're referring to a point, for example, in two-dimensional space, so let's take the simple case first. Okay. It takes exactly two quantities in order to be able to represent the position of that point. Okay. A point, of course, does not have any orientation properties, it only has locational properties. So we're very familiar with this. If we have a Cartesian XY coordinate system, a point is represented by its x coordinate and its y coordinate. If you extend that principle to three dimensions, then that would be an x, a y, and a z coordinate. So now we're talking about 3 degrees of freedom. If you extend the concept from a point to a rigid body, a solid body, now it not only matters where that body is, but what orientation it takes. So at that point, you actually jump to 6 degrees of freedom. It takes 6 numbers to fully and uniquely represent the location and the orientation of that body, again, relative to some fixed coordinate system. So we will have 3 numbers in there, let's call it the XYZ coordinates, and normally those will point to the center of gravity or the center of mass of the object. And then we will have 3 additional parameters that will give us the orientation of that body. And those numbers will in fact be angular quantities. They will be perhaps angles relative to the main axes, to the main x, y, and z axis. Okay. So let's see what that looks like here with this representation. Okay, so here you see a collection of 3 axes in there represented by the red, yellow, and blue colors. And those would be locations, or let's call them translations. Now here they're represented as forward, right, and up, and then their complementary motions and back, left, and down. Now in addition to that, we have 3 quantities that are rotational in nature. And here they're described as roll, pitch, and yaw. Okay. And it's the combination of these 6 quantities that give us a unique location in space for an object. Let's now superimpose this on an airplane, staying with our aerospace theme for this lecture, and you can see now exactly what all this means. Okay, so we have the arrows pointing towards the front and the back of the plane. Okay, so that would be, let's say, some longitudinal distance of the plane. Up and down would represent the altitude. Left and right, might represent the latitude of the plane. And then at the same time, to fully represent the location of that airplane, we have the roll condition, so the green arrow. So you can picture the roll as happening about the longitudinal axis of the airplane. You have the pitch angle, that's the up and down nosing of the plane, if you will. So that's relative to, let's call it the axis that would go through the wings, if the wings were not to be swept back. And then finally you have the yaw. Okay, the yaw is the motion that occurs laterally, so left and right, and therefore about the up-down axis or the vertical axis. Okay, so when we have a part fixed, completely fixed, and now we can translate all this, to the realm of assemblies. Okay, when a part is completely fixed and it is unmovable, we speak of that part having no degrees of freedom, having 0 degrees of freedom. We have removed its ability to translate or rotate in any of the 6 possible directions. Okay. Now, if we have relative motion between assembly components in a part, it may be that we disallow a certain motion. For example, we may disallow the ability for that part to translate in the x-axis, but we may still allow it to translate in the y-axis and potentially also the z-axis. Okay. Similarly, we may allow a rotation about a particular axis, but disallow it around other axes. The process of assembly is the process of removing degrees of freedom from a component, starting from 6 in its natural state, if you will, okay, and until all the degrees of freedom or the necessary degrees of freedom have been removed for that component to make sense within that assembly and to perform the intended function within that assembly. The way we remove degrees of freedom is by adding constraints. And that should be very reminiscent of the constraints that we added when we were sketching. It is in fact the same concept, but applied at the assembly level, at the 3-dimensional level. Okay? It is important that you think of this in terms of degrees of freedom, train your brain that way, and also, you'll pick that up, that competency, and apply it in other fields of engineering, as I mentioned before, solid mechanics, rigid body dynamics, and so forth, where it is fully relevant. Let's now look finally at how we do these things in SolidWorks.